Okay, so maybe now is a good time to look at lists and try to figure out how do we add an item to it, which we've seen before with the append. How about removing stuff from it, right? So let's go ahead and do it. So let's do it all in main within the same program right here. Let's say we have my list equals a bunch of items. And let's say it has, again, Drew here, Bob here, and let's say it has Henry here. Okay. All right, fantastic. So we know if we printed this, we could use a for loop if you want, or you can simply print my list. You could do a print my list if the list is small. Otherwise, it's a good idea to use for loops or while loops to step through a longer list and handle it in that manner. But at this stage, just for visual effect, we're going to print the initial list items are, and then we could do just simply print the list itself, my list. Okay, so we're not going to do a loop. We're just going to look at what's in there, run it, and here they are, Drew, Bob, and Henry, right? So we got a little message here explaining what that is. All right, so now how about adding Janet to the list? Okay, we've seen that before. We've done an example like that where we added Villa to our list. We're going to do the same thing here. We're doing everything in main. My next exercise, I will do things with other functions, okay? So right now, I'm just going to consolidate everything in here. The reason is I want to show you how to remove an item. What are the two different techniques you can use to remove an item? So first, let's do review. How do you add an item, right? So in our case, say we wanted to add Janet. So you can actually take the list, my list, and use a method to append whatever you want. Make sure you put between two quotes a name. If it's a number that you want, then leave it as a number. Whatever data type you desire will be appended. Remember, the list will take a list of different data types. It's not important. For the sake of this exercise, it's all the same. But for us, we'll do it. And we'll put Janet here. Okay. And now let's go ahead and let me copy this. And we're going to print it again. But this time, the modified list. List items are, and after adding an item. And let's see what happens. As you can see here, after adding an item, we have Janet here. Okay. Now, data handling. We want to delete some stuff, right? So we've seen how to add. The thing with append, it always append to the end. So if I want to do it again, if I do another append, it will append to the end of the list. Let's prove that just for the sake of it. And let's copy this here and do it again. Now, could we append Janet again? Sure. I mean, just show you print and then my list without any message here. Just show you could have the same item twice right here, Janet and Janet, right? So there is nothing that says any of these items have to be unique. This is very important for this data structure. Now, we're going to see some other data structures in the future where all items in here have to be unique. Okay, so in our case, no. You could have duplicates. That's fine. So let me just take it out that we've seen that's feasible. There's nothing stopping us from having duplicate items or in the list. Not a big deal. Now, how about removing Janet? Well, you have two ways. If you want to remove Janet, which was anybody here, think of this as a stack. You can pop the stack, which means you can use the pop command or the pop method to remove the last item that you put in. So last in, first out. This is what we call a LIFO, right? So this is going to be a LIFO type of access, right? So sometimes in computer science, you might hear the word LIFO means last in, first out, okay? And that means if we want to, by using the pop method, that's what's going to happen. So my list and you simply say dot pop. You don't even tell it what is it you're popping. It automatically pops the last item you put in. And if we print the modified list after popping the last item, then we could do, let me spell popping better, okay? And we're going to do my list here. All right, so we're going to type my list and see if Janet disappeared. And sure enough, Janet disappeared. So what if I keep popping? Well, let me copy this and see what happens. Then Henry disappears, right? So as you can see, we're stepping through. Think of it as a stack of plates. The last plate you put at the top is the one you're going to take out. And then the one after and the one after until you reach bottom. Okay? We will do exercises to make sure we limit our popping to the last item, right? So, and then the list is empty, so we don't run into issues. So is there another way to delete without popping, which means you can pick an item based on its content? What is it exactly? Let's say we wanted to delete Henry and not use pop, right? So let's remove pop. So I'm just going to take out pop. So now it's no longer LIFO. It will be specific. So think of it as a surgical operation. So first let's run this. Notice Janet is in there. And we're going to want to remove Henry. So the way to do it is my list. And we're going to do dot remove. And you have to be very specific now who you want and spell it exactly the way it's spelled out in there. Henry, right? It's case sensitive. That's what we want to remove. So now we're going to print. So now you can see this is no longer popping, which means at the top of the stack, this is now specifically targeting an item within the list. So there's a major difference between remove and pop. Yes, they both remove an item from the list, but they do it differently. So the modified list after removing Henry let's see here, just Henry, and let's put a comma here, and that would be my list. Now you could do a for loop to step through all of this if you want, but you could see Janet remained because this is not a pop operation, this is a remove operation, and it went straight to Henry and removed it for you. So these methods allow you to do certain things without inventing a lot of code. It's already there. So how do I, again, look at what methods are available? So my list, and if you do a dot, you get a list of things you can do, right? And notice here, you even have an insert, which we will do an exercise with that, but you can tell it exactly where to insert. Notice it takes an index, and then the actual object. So you can tell it where to insert it. Well, heck, let's do it. And let's insert at index 2 item Kelly. Let's see what happens when we print the modified list after inserting Kelly at index 2. So it's very specific what this operation is. And then we're going to type my list here. We want to see if indeed Kelly was inserted there. All right, and Kelly is indeed at index 2. Now remember, Drew is at index 0. Bob is at index 1, right? And notice we inserted Kelly where we had between Bob and Janet. Janet was at index 2. Now Janet is at index 3. All right, so our next exercise, we're going to delve again with lists. Use some of these examples, but do them within functions. We'll do a little bit of an exercise that will make a lot of sense in terms of putting a context with it. So we'll meet you again. I'll see you then.